In this blog we are going to look at the house main electrical panel. Connecting homes to the electrical grid is the final stage of the electrical grid. After the substations have stepped down the voltage to acceptable distribution levels, this stage may be accomplished. Wires lead off from the neighborhood's power lines and connect to individual buildings, homes, apartments, and businesses. But first must go through the electric meter to measure how much electricity the customer uses. The electricity then passes through a service panel, which houses the electrical safety devices, circuit breakers or fuses. This service panel has all of the wires that run to the different electrical outlets around the house. Every home is connected to the electrical grid through some sort of fuse box or circuit breaker panel. The overhead power connection from the utility lines to the service entrance is referred to as the service drop. It has 3 wires. 1 neutral line, and 2 hot lines. The hot lines maintain a certain potential, like 120 volts, compared to the neutral line. There are 2 types of overhead service drops, a masts service drop, and an underground service connection. The service connection enters the panel via the main disconnect breaker, which is utilized to isolate the complete home by stopping all electrical power flow. This is positioned in between the service meter and the rest of the electrical panel. The main disconnect is a circuit breakers housed in the electrical panel. In order for this to work, the circuit breakers must be in series with the 2 hot lines of the conductors, because it must cut power to all circuits. It is rated to be able to interrupt the total household load. A circuit breaker is an electrical switch that cuts off electrical flow in the event of a possible short circuit or overload. This device is essential in a modern world that runs on electricity. Without a circuit breaker, you could find yourself dealing with household fires on a regular basis. While you can easily call a professional electrician, you can also learn how to wire a circuit breaker yourself, with relative ease. Because most power panels today are breaker panels, I'm going to deal exclusively with breaker panels. If you are to do any work inside the main breaker panel, the first thing you must do is switch off the main power switch or breaker. This is usually, but not always, at the top of the breaker panel. It should be the largest switch breaker in the panel, and will also be rated the highest ampere rating in the panel. Take the cover of the breaker box off. It is usually held in place by 4 to 6 large screws located on the perimeter of the cover. You may accidentally trip off some of the lower voltage breakers when doing this. However, this is not a problem, as long as you remember to switch them back on when you're finished. This is a sketch of what you will find inside a standard power panel. At the top, in most instances, is the main breaker. The 2 hot wires from the utility will be connected here. The neutral from the utility is connected to a neutral bar, which can be located on either side, and, sometimes, on both sides of the panel. The ground bar, that receives all of the ground wires, is located on either side of the power panel and can be identified by its connection to the ground rod. All of the circuit feeder breakers are located in the middle of the panel. Cables from the various outlets in the house enter the panel through knockouts that are located on the perimeter of the panel. The hot wires are connected to the breakers in the middle of the panel, while the neutrals are connected to the neutral bar, and the ground wires are connected to the grounding bar. Depending on the size and gauge of the wire, a knockout bushing must be used when stringing the wire through the panel side. This bushing, for number 14-3 wire and number 14-2 wire, is usually half an inch, but the knockouts and bushings could be as big as 3/4 of an inch. The bushing not only protects the wire from the sharp edges of the panel box, but it also locks the cable and wires in place. This picture shows the installation of a single pole breaker, protecting a 120 volt, number 12-2 cable. A double pole breaker, protecting a 240 volt, number 10-2 cable. And a double pole breaker, protecting a 120-240 volt, number 10-3 cable. With the breaker switch in the off position, install it on the main bus. Many breakers have a hooked outer edge, slide it into the hot bus bar until it engages. Then firmly push the other end down, over the protrusion on the breaker until you hear a click. This diagram illustrates some of the most common circuits found in a typical 200 amp circuit breaker service panel box. The breakers are installed in a panel so that contact is made with one or both of the hot bus bars running down the middle of the box. The hot wire for a branch circuit is connected to the breaker by a set screw on the base. The neutral and ground wires for the circuit are connected to a bar along the side of the service panel box. The neutral and grounding bars in the panel may be separate, or, in the case of older service panels, the same bar may be used for both purposes. This wiring diagram illustrates installing a 15 amp circuit breaker for a 120 volt branch circuit. The 14-2 cable for this circuit includes 2 conductors and 1 ground wire. A 15 amp circuit is usually used for wall receptacle outlets and light fixtures. This diagram illustrates the arrangement for a 20 amp, 120 volt, double receptacle circuit with a shared neutral wire. This arrangement is typically used in a kitchen or over a workbench where 2 separate appliance circuits are needed in close proximity to each other. Notice that the breaker is a gang breaker, which means that it switches or trips both circuits at the same time. This arrangement is absolutely protected, but can supply a total of 40 amps from a 20 amp breaker, provided that the load is evenly split between the 2 receptacles. This circuit breaker wiring diagram illustrates installing a 20 amp circuit breaker for a 240 volt circuit. The 12-2 gauge cable for this circuit includes 2 conductors and 1 ground. The white wire is used as a hot in this circuit, and it is usually marked with black tape on both ends to identify it as such. A neutral wire is not used in this circuit. A dedicated 20 amp circuit, like this, is used for a heavy household appliance, like large window air conditioners. This is an outdated circuit that may still be in use. This wiring is for a 30 amp circuit breaker, serving a 30 amp, 240 volt receptacle. The 10-3 cable for this circuit has 3 conductors and no ground. Although the newer installations will have a bare copper ground. A 30 amp circuit like this may be found in older installations for clothes dryers and maybe a kitchen cooking range as well. This is a diagram for a new 30 amp circuit breaker to serve a 30 amp dryer outlet. This is an upgrade of the outdated 30 amp circuit in the previous diagram. This breaker is connected to a 30 amp receptacle with a 10-3 cable, including a ground wire. This diagram illustrates the wiring for a circuit breaker with a built-in ground fault circuit interrupter, or GFCI. This 20 amp, 120 volt breaker is a form of GFCI that can be installed at the circuit source. This kind of circuit is used for dishwashers, whirlpool spas, and other locations where water contact is likely. This information, as well as other related electrical blogs, may be found on my website at https://www.getpspt.com. There you also have access to my courses, which are continuously being added to and at the present time include the following.